So let's read the problem. Stephanie's annual salary, S, in dollars, after working at the same company for T years, is given by the function S of T is equal to 45,000 plus 2,000 times T. Okay, complete the table showing Stephanie's salary after each year. So here's what I like to do. This is a pretty difficult question. I'm not even going to do the work yet. What did Stephanie start with as her salary? 45,000, right? How'd you know that? At the beginning, adding 1,000 every year. Okay, so linear? Is it constant? Is this constant? Okay, so these are the type of questions that we're going to ask ourselves today. Because if this, another way of writing S of T is equal to 45,000 plus 2,000 T is Y is equal to MX plus B. So I'm trying to make sure that we see through the different modalities, because this is something that we're going to practice today, but it's just something that you have to realize, all right? So when we're dealing with linear functions, remember Y equals MX plus B is what we're going to deal with, and B is the Y-intercept. This is the Y-intercept, 45,000, that's what we start with. So the work is, I gave you a hint. I'm going to plug in the first year, 2,000 times 1 is 2,000. 45,000 plus 2,000 gets me the first year of a salary, which is 47,000. Okay, that's a 0, not a 6. Don't judge me. Okay, so here's the work for the rest. Please write this out. Everything should be completed. Every single one of those functions on the right, please write the rest of it out, unless I saw you get the right answer, which is cool, okay? Another thing that they could say is, how many years did it take Stephanie to get to $55,000 a year? 5. All right. The constant question is the one that I presume that they'll, if it's linear, there's just certain characteristics of linear functions that we're going to have to remember. With quadratic, there's certain things with quadratic functions that we just have to remember. Same with exponential. All right, so when you get done copying that bell ringer, please put that bell ringer away for me. And we could take out our notes for F-IF.3.9. I am passing out your parent or guardian letter for the EOC boot camp. This is how close we are. I'm passing out a letter that's informing you of the boot camp that we are doing, okay? There's the dates on here. If you show up, we have a way of remediating a summative grade in any quarter. Okay, we're trying to find ways to incentivize all of you to come. All right. So if you look on the second page of this handout, it asks you to fill out some information. All right, I'm going to also be sending out an email to your guardian and parent. Could I give you one, Mr. Gomez? I'm not forcing, I can't force anybody to come, but I would highly, highly, highly recommend it. Okay? It will help immensely. It will give you more one-on-one time with your teacher. It will help immensely. All right, you'll be dealing with me and Miss Huff across the hall, and there's been a lot of planning going on involved this, just so that it's not just sitting here like you do in class. We're going to be doing other activities that will get you to review for your EOC. All right, if you so choose, you want to fill that out, you can fill it out, rip the back out, and turn it in whenever you get a chance to. But let's go ahead and start this review. All right. So our review today is of standard F-IF.3.9. This standard states we compare properties of two functions, each represented in a different way, algebraically, graphically, numerically, in tables or verbal descriptions. For example, given a graph, one quadratic function and an algebraic expression for another, and say which one has a larger maximum. I have a couple more examples over here. All right, watch your eyes. So 3 different ways to represent a function, algebraically, graphically, numerically. So this is a quadratic versus a linear function. The quadratic's in a table, the linear function's on a graph. They ask, what do these functions share? Well, you would have to think. Linear functions are constant, quadratic functions are not. They start in the same place, 0, 0. Okay, they have the x and y-intercept that they share. Secondly, this is linear function versus exponential. The exponential is on a graph. The linear is in a table. It says which one increases faster between the interval 3 seconds to 6 seconds. So between 3 to 6 seconds, you would find the slope for both. In this case, the linear is faster. All right. Third, this is an exponential function represented algebraically. This is a graphic quadratic. Do these functions share something in common? They all share the same intercept for the y initially, right? And then if you have issues, this is the one where I'd look. Okay, so what comparisons can be made? Are the intercepts, do they match? Are they constant? Are the slopes similar? Are they different? The three different types of functions that I think you're going to see the most of are linear, quadratic, and exponential. I've given you each one of the functions. I've given you a couple pieces of information to think about with each one of the problems that you see. Okay. I say this with all sincerity, watch us. I wish I could teach you as well as one of these quizzes does, because literally last period, I had a student say, Mr. Wilson, so I like literally learned, and don't laugh because this is sincere, okay? He said, I learned that on a graph, a linear function stays going the same direction and it doesn't change. It's not wavy. I know that a polynomial is the wavy one that does it more than once. Okay, so this is the end of the year, and I've sincerely done my best every single day to convey concepts, right? It took one student reading a question, getting it wrong, and doing that question again by themselves to understand a concept, okay? That concept's been talked about almost every single day. That has nothing bad to say about that student or my instruction as an educator. It's that you all have the ability to do amazing things with this thing between your ears. It's whatever you decide to put it to work to do. The student first period literally got annoyed by the question, so he redid it, and he gained a piece of knowledge that can't be taken from him. I'm not saying you have to do this in my math class. I'm not saying do it. I want you to. I hope and pray that you do. The one thing that I really, really want y'all to take from at least being a student of mine is that this thing between your ears will take you wherever you want to go as long as you are the master of it. Okay? It's Monday. It's rainy outside. It's hotter than normal and it is in here, but how much will and focus do you have? And that goes with any situation, all right? In your life, any situation, if you can push through, you'll do great. All right, so let's go ahead and start with a problem. I kind of did a very, very bad job graphing the second line, but let's read this problem. Okay, the graph models Jeremy's distance in I did the same thing first, kilometers from school along the bike route after 2 minutes on his bike. So this line that's not red is his bike distance, okay? The equation D is equal to a negative 1/2 t plus 6 models Jeremy's distance in kilometers from school along the bus route after 2 minutes, okay? So what they did was they gave you a graph. They gave you a graph of a linear function for his bike. Then they gave you an algebraic representation of the function. Y is equal to mx plus b, okay? So I know that if I want to compare the two, I either have to look at this, y equals mx plus b, and understand where it starts and where it's going, or this is what you pretty much have to do, graph it, okay? So looking at this function, what's the first point that we always graph with any linear function? The y-intercept. Where's the y-intercept found? Yeah, 6. It's 0, 6, because that's the b. So that's the first point that I graph, 0, 6. And then here's the second part that's tricky. This is what I would bet that they're going to do on the EOC. It's foolish. It's a little tricky, and I don't like it, but it's the truth. If I went from this point and said that my slope is a negative 1/2, okay? If I went down 1 and over 2, what did I just do wrong? If I went down 1 and over 2 to the right, negative slope goes this correct. That's not correct, but I appreciate you asking. I want you guys to guess. So if I went down 1 and over 2, what would be incorrect? This is the correct graph. But if I said I went over 2, what am I actually doing on this graph? So what are the units for the x-axis? Are they just singular like this? No, they go up by 2s, right? That's the other part that you can make a silly mistake with, because I did. I literally, first period, went down 1, over 2, down 1, over 2, and then I got halfway through the problem, and I'm like, wait, I've already done this and something's wrong. Then I looked, okay, so if I go 1 unit to the right, that's actually 2. So down 1, over 2, down 1, over 2, down 1, over 2. So please graph this line. All right, and let's talk about the problem. The first question says, which mode of transportation travels farther to get to school? Can somebody, which one travels farther? Is the y or the x-axis about traveling? The y, okay? So what would indicate that the distance is further if we're dealing with the y? The higher up, the y-axis. So which one? If the bike path is black and the bus path is red, which one has a longer distance to travel? Yes, very good. The bus does. Okay, so please copy this. So here's the beautiful thing about me being a teacher. I have examples that I'm going to give you. I'm going to ask you questions. If you guys don't want to play along, I'll just put you on the quizzes and y'all get to work. I can't force you to ask questions. I pray that you guys do, but I can't. I can't make y'all do anything. I have no power. I can only beg, and I don't like to beg that much. So the question says, which mode of transportation travels farther to get to school? Explain how you got this. Well, the bus, it's 6 kilometers away. That's where the y-intercept is. The y-intercept for the bike path is 0.4. So it's shorter. It's 2 kilometers shorter than the bus path. And then the second part of the question, which mode of transportation takes less time to get Jeremy to school? Well, X values are your time at that point. And which one has a lower X value? The bus path. So the bus. Please just copy for me. If he tells us to move, please move in the safe area. And then please just copy all of this for the second problem. Please copy what you see and I'll explain it. So if this was a real shooter drill, there's safe spots that you guys all know of. Is this open or something? So make sure you draw the graph for me. It's up 4 over 1 for the linear, because the function is C of H is equal to 4H. Another minute and then I'll explain this problem. Okay, so all I did was take the interval of 1 to 3.